Hello, this is Debbie Collins, and we're going to start this course talking a little bit about computer hardware, the history of it, and there really is some fascinating facts here, I think. And we'll also look at a concept called abstraction. But this video just covers computer history, the hardware aspect of it. Some of this is in Chapter 1 of the Computer Science Illuminated Text. Also in the Computer Science Illuminated Text, Chapter 1 is History over Software, and we'll talk about that a little bit later when we're talking about programming languages. But before we get started, I'm going to take a look at defining a computer, and many of these items here you probably are familiar with. Got input devices such as keyboard, scanner, digital camera. We have here also the processor, okay, and inside the processor we have the CPU, which carries out the instructions of a program, and we have RAM that stores our program and our data. Here's our hard drive or storage device, and there's some output devices. Sure, you're familiar with all of these. So these make up the basic components of a computer. So do know this pretty well. We're looking at 5 basic components of a computer. The input devices, okay, and the output devices here, and the storage devices. Then within the processing unit itself, you have 2 parts, the CPU and RAM, internal memory, main memory. So can you have a computer without all 5 components? Well, let me tell you a story about this. Back in the mid-80s, I was going to school and I took my first computer class, and my mom bought me a Commodore 128. You may have heard of it. Actually, in the early 80s, the Commodore was actually the #1 selling brand of computers. So the 128 meant that there were 128 kilobytes of memory. That's what the 128 stood for. So she bought this, and I want to talk about the components. So as you can see, there's the keyboard, okay, and it had a processing part to it. So I had input and processing. Now what about output? Now, by the way, the processing included RAM and the CPU. Now what about output? There were cables that connected to my TV set, so that became my output. But what about my secondary storage, like my hard drive? She did not get that for me. That was an extra component. It cost extra money, and she did not purchase that for me. So I was missing that component. Could I still use the computer? Well, at the time there was this magazine that came out, and I subscribed to it. It was called Compute Gazette. And in that magazine there were articles, there were programs that I could write in the programming language BASIC. And you may have heard of BASIC. And I would write these programs. At the time my son was in 5th grade. Let's say, for example, I would write a program that helped him do his math homework. And so he came home from school, he did his math homework, then he wanted to watch Inspector Gadget. So since the computer was hooked to the TV, he would have to turn the computer off. So what happened to my program? There was no storage device to save it to. In fact, there was not even a hard drive. If I really wanted a storage device, it would have been a 5.5-inch floppy drive I would have had to save it to. So because the computer was turned off, all that code that I had just written was gone. And so the next time we wanted to run that program, I had to rekey it in all over again. So did I really use that computer? And the answer is no. The following Christmas, my mom bought me the storage device, and I did start using it a lot more. So you really do need all 5 components to have a practical computer that you would use. Okay, with all that, here's my definition of a computer. A computer is an electronic device. Notice that I did highlight electronic device. Okay, we do, because there are devices that we could say it has input and output and it processes, but it's not electronic. So we would not define that as computer. It gets this data, how? Well, through an input device. What's it do then? Well, then it processes this data. Okay, the data goes into internal memory. As the instructions need that data, it puts it into the CPU and does the processing, back out to memory where it's output. Okay, So the processor uses the instructions that a programmer will write, changes the data to a usable information. Okay, but what about storage? Well, you notice that storage could do both. Storage could be where you retrieve data, raw facts, or it could be where you store the information. So suppose the result of running a program is an essay for your English class, okay? And you can save that. You don't have to print it out, right? So another thing you can do with that, that's your information, it's my essay, you can save that. So information can also go to storage. I'm going to pause here to let you know that I expect you to know those 5 basic components of a computer, and I guarantee will be asked on your midterm. Okay, let's go on to computer history. Okay, so let's start off. Here's some non-electronic devices. I kind of emphasize that computers are electronic. So we have, for example, the abacus maybe being the first non-electronic device that did some calculations. Here we have a punch card, and a punch card here was used for a loom, and a loom is a device that weaves cloth into certain patterns. So this, hit my pen here. So this is actually was the input, okay, and the loom would read that input and make cloth patterns from it. You might have seen punch card technology on a player piano uses that. Takes the paper with the punches in it and plays the piano. We almost got in the mid-1800s close to an electronic computer. Here's the problem. The first mechanical computer. It uses gears and axles. Oh, that sounds like a car. And it could process and store 40 digits. It had storage. It had processing. Like the loom, it used punch cards for input. Okay, so let's go into how storage is happening. So storage uses something called switches. Like a light switch, it has 2 states. A light can be on, a light can be off. So similar to the electronic switches that are in the computer. So what we do with looking at the hardware history is we define generations based on the different switches that were used. Initially, the switches were large vacuum tubes, and the switches became smaller and smaller and smaller, so small that we now have phones that are more powerful than the first computers, which took rooms up. The first generation then used this vacuum tube. That was the switch used. So each of these could be in the state of on or off. And the very first electronic computer, known as the ABC computer, was founded actually in Iowa State University. So I get all excited when I get to this part, that our area has so much to do with the creation of the first computer. Dr. James Tanasoff, he created it in the late 30s, 1939 or so. The motivation was solving systems of linear equations, that it took too long to use that dang slide ruler. Have you ever seen a slide ruler before? Yeah, so that's how you solved equations that were complex. Back then, you used a slide ruler, and I've used a slide ruler, giving my age away a little bit. Took too long, so he created an electronic computer. And it used vacuum tubes. Look at what it used. It used electricity. It was base 2, and we're going to be talking about base 2 or binary. You may have heard of that, but computers now, that's what they use, base 2, they're binary. And he had a memory, okay, and he used logical action, and we're going to talk about what logical action is when we study algorithms. That's what computers do to calculate. The first generation was bought by the U.S. Census Bureau. Actually bought the first computer. Before that, during World War II, some universities created very large computers. They were used for ballistic calculations. Germany, I think, had their version of a computer. Britain had their version of a computer also. But in the U.S., the Census Bureau used it. It cost over $1 million. That first generation, they were large computers. and 46 were built. And the first that went to a non-government sale was to General Electric. I want you to take a look.
UNIVAC, the giant electronic brain made only by Remington Rand, takes business statistics from magnetic tape, letters, numbers, and punctuation marks, processing them through its electronic circuits at phenomenal speeds. UNIVAC can compute payrolls electronically, then produce printed checks in a flash. Over 8,000 checks an hour with this high-speed printer. UNIVAC leads the field of electronic computing.
So you see that the UNIVAC did look pretty large. You saw the vacuum tubes that were being used. Here's a little bit more on the UNIVAC computer.
This is weather, one of nature's ever-changing mysteries. It affects every one of us every day of our lives, and yet we know relatively little about it. Weather, that's something we'd all like to do something about, isn't it? And so tonight we've brought you down here to Remington Rand's New York Computing Center in order that we might show you that something actually is being done about it. The hero of our story tonight is the giant electronic brain developed by Remington Rand, UNIVAC. Now, recent experiments show that future use of UNIVAC may give us faster and more accurate weather predictions than were ever possible before. You see, UNIVAC can take the past histories of thousands and thousands of storms, analyze them, compare them with developing conditions, and make predictions, all in a matter of minutes. Calculations that would ordinarily take hundreds of man-hours to complete. Data from guided weather rockets, radar observation stations, weather stations, all of this can be fed into the computer through these magnetic tapes at a rate of 12,000 numbers or letters per second. The memory tanks make immediately available 12,000 additional units of information. And all of this complex weather data is analyzed in the heart of the UNIVAC, the electronic central computer, capable of making over 2,000 mathematical calculations per second. Now, here is where we get the answers. You might call it the voice of UNIVAC. Actually, it's a high-speed printer that prints results at the rate of 600 lines a minute. So you can see that UNIVAC is both fast and versatile. But most important is the assurance that UNIVAC will give you the right answer.
You might have noticed that the announcer mentioning a unit of information. That unit information we now call a byte. I'm sure you've heard of that term. And when he said 12,000 units, wow, that would be about 10 kilobytes. And a typical HTML page without any images are 5 kilobytes. So what was so large back then is a drop in the bucket to what we do now. Okay, so here's the second generation. What is the switch? It's this little thing called a transistor. So it is quite smaller, and no more vacuum tubes. So it became smaller. The heat of the vacuum tubes was a concern actually for those large first generation computers, and with the transistor that problem went away. So here to demo the difference, I'm using a radio. A radio was something large that sat on a desk back when it needed vacuum tubes. And then once transistors came effect in the 60s, I remember transistor radios. Wow, you can put a radio in your pocket. That was amazing. One of the new type of computers that came out was called the mini computer. Now, you might look at this image here and say, that is not miniature. But compared to the first generation of computers, this was considered mini. The price of the computer went down to a reasonable $125,000, and computers started finding their way into universities. Now, the third generation of computers was from 65 to 71 and used this newfangled device called an IC chip. So an IC chip, you've probably seen these on motherboards if you've looked at the hardware inside of your system unit. So it uses silicon. And originally there were 4 switches on one of these. Okay, so once again we can get smaller because now we're doing, this space could do 4 switches. And now we can put billions of switches on one of these. So one of the big companies in IC chips, you may have heard of Intel. And the co-founder of Intel, Gordon Moore, predicted in 1965 that the number of components or the number of switches on an IC chip would double every year. So let's say that every 2 years, excuse me. So let's say at that first year there were 4. So 2 years later there would be 8. 2 years later there would be 16. ... Well, he said that would happen for 10 years, right? Almost 50 years later, Moore's law is still holding true. That is amazing that someone had the foresight to predict that. And this is what's led to the ability to put a computer on a phone now. Let's see, some people say Moore's law is self-fulfilling, that there's scientists, computer scientists out there, electrical engineers, they know Moore's law, so their goal is to find a way to make it come true. That may be true. So the latest technology to keep Moore's laws true is IBM's nanophotonic avalanche photodetector. Wow. So it keeps on going. I'm going to continue on. 4th generation, well, that's what we're in now. 2 new types of computers came out, started in 1972. And the desktop computer. Wow. A computer so small you can put it on your desk. And with Moore's law coming true by the mid-70s, the IC chips were powerful enough to make these types of computers. So the very first desktop computer was a kit you actually mailed away for. There was a magazine, I think it's still published, called Popular Electronics. And this is the cover of the magazine introducing the Altair 8800. Save over $1,000. Wow. So people like to piddle around with electronics, and they created their own computers. It did not do a lot. However, a year later, Steve Wozniak and Steve Jobs created the Apple computer in their garage, and that became big. You know the history of that. And with IC chips holding more and more switches, I already mentioned, we can put a computer in our pocket now. The other type of the computer that came out in 1976 was the Cray 1, which is our first supercomputer, massive supercomputer that can do calculations, and you can find the Cray 1 was at the University of Illinois. My question to you is, what's the 5th generation? What's the future? We will see.